Hey guys, this is going to be the lesson for Unit 10, Day 6, Trig Expressions and Identities. I'm not going to take time to go over the warm-up. You can check those. You should practice them, but you can check them on our Schoology page for the answer keys. We're going to jump right into simplifying some expressions right here. Now, before I do this, I just want to remind you guys that we talked about in our notes all your reciprocal functions, your rational functions, and your Pythagorean identities. So what I'm going to do here, the goal is to try to rewrite all of the tangent, cotangent, secant in terms of sine and cosine, and then perform the operations. Start right here with number 1. Sine theta, that's not going to change. So that's just going to stay sine theta. Secant, if you remember, over cosine. So I'm going to change this to over cosine. Now I'm going to be multiplying these two fractions. So what does this get me? Well, this gets me sine theta over cosine theta, which we then can substitute in a single trig function for that, and that is tangent theta. And we've simplified it from the original to a tangent theta, and we're going to stop there. All right, moving to number 2. We've got cotangent squared times sine squared. Now, if you remember, cotangent is cosine over sine. So cotangent squared is going to be cosine squared x over, and sine squared, there is something, if you notice, you're going to have to multiply those. The sine squareds cancel out, and that just leaves me with cosine squared x. And that is simple as we can get that. Moving on to number 3. Secant theta. Let's replace that with 1 over cosine. Cotangent theta is with sine over sine. And sine theta just stays. Now, again, pretty nice. If you notice here, we're going to multiply across, but guess what? Cosines cancel, sines cancel, everything cancels, and we are just left with a 1. It's kind of nice when that works out. All right, my next one here, they give us the division symbol. I prefer to write these as fractions. So we're going to have 1 minus cosine squared a over sine a. Now, for the first time today, we're going to use a Pythagorean identity. You should remember that sine squared plus cosine squared equals 1. So 1 minus cosine squared we can replace with sine squared. And then this sign in the denominator will cancel with one of those in the numerator, and I am just left with sine of a. Again, the goal is to simplify these expressions. If possible, write them as a single trig function. All right, moving on to number 5. Tangent theta times cosecant theta. Again, it's just about substituting in. So tangent theta is sine theta over cosine theta. Cosecant is 1 over sine theta. So what will happen here, the sine theta will cancel, and I'm left with 1 over cosine theta. Now, when possible, I prefer not to have a fraction, so 1 over cosine theta is the same thing as secant theta, so there's my single trig function that is simpler than the original expression. All right, number 6, cosecant, 1 over sine. Tangent is going to be sine theta over cosine theta, and cosine theta just stays. So, like the one we just saw up above, sine thetas cancel out, cosine thetas cancel out, everything cancels out, so we're just left with 1. All right, the last two we'll practice here when it comes to simplifying expressions. And again, the more of these you do, the more the tricks you'll pick up. What I'm going to do with number 7 here first is I'm going to rewrite cotangent A as cosine A over sine A. Cosecant I'm going to write as 1 over sine A. And then notice I'm multiplying that expression by sine A. So basically what I'm going to do here is I'm going to distribute sine A to both of these. Well, guess what's going to happen? When you distribute that, it will cancel with each denominator. So I'm going to be left with cosine A minus 1. And unfortunately, there is nothing I can do to simplify that anymore. All right, moving on to number 8. All right, so we'll replace the secant theta with 1 over cosine theta minus sine theta times, now tangent theta I can rewrite as sine theta over cosine theta. So now what I need to do first is I need to multiply this expression before I can subtract it from 1 over cosine. Watch what's going to happen. I've got 1 over cosine theta minus sine squared theta over cosine. Now normally you'd have to get common denominators, but we already have them. I can combine my numerators, 1 minus sine squared theta over cosine theta. And Pythagorean identity, 1 minus sine squared theta is the same as cosine squared theta. So now I've got this expression cosine squared theta over cosine, and the cosine in the denominator will cancel with one of those, and we are just left with cosine theta as our simplified. Okay, so now we're going to tackle some identities. Now, if you remember from last week, we said an identity is different from an equation. Treat the equal sign as a wall. All right, so basically we have two separate expressions on each side, and what we want to try and do is get those expressions equal. So I'm going to start with the easiest side. Cotangent theta can be replaced with cosine theta over sine theta. Now over on the left side, I'm going to have to combine these two things, which means I need to get common denominators. So first of all, let's take tangent theta and rewrite that as sine theta over cosine theta. So I'll copy the first expression down, minus sine theta over cosine theta. So now what I need to do is I need to get common denominators. Well, it's got to have sine theta, cosine theta in the denominator. So what I need to do now is I need to take this expression on the right and multiply it by sine theta over sine theta. So what that gives me now is 1 minus sine squared theta in the numerator, and my common denominator is going to be sine cosine theta. Well, now what I need to do, I need to replace this expression, 1 minus sine squared, if you remember, is simply cosine squared theta. And my denominator is sine theta cosine theta. Now what happens is this cosine and denominator cancels with one of those in the numerator. And guess what? I'm left with theta, which is exactly the other side. Okay, let's move on to another one. All right, so again, I've got cotangent theta on the right side. We just did this. We know that's cosine theta over sine theta. So now the question is, how do I get that expression to equal cosine theta over sine theta? Well, there's no addition or subtraction involved, so that should make it a little bit easier, but it looks like it might change flip. I'm going to rewrite tangent theta as sine theta over cosine theta. Cosecant squared is going to be 1 over sine squared theta all over secant squared, which is 1 over cosine squared theta. So what I'm going to do now is I'm going to try to clean up this expression in the numerator. All right, so I can see what's going to happen when I multiply those. That sign there is going to cancel with one of these here. So I'm left with 1 over sine theta cosine theta over 1 over cosine squared theta. Well, now we're going to do our copy, change, flip. We're going to copy the numerator, change this to multiplication, and flip that denominator. Now what happens is I have a cosine in the denominator. They'll cancel with 1 in the numerator, and I'm left with cosine theta over sine theta, which is exactly equal to the other side. So I've now just proven that identity. Okay, 2 more. Number 11. Well, obviously the right side is going to stay cosine theta. So somehow I have to simplify this expression here. And again, it's all about the substitution. Cosecant, 1 over sine theta, times sine squared theta, times cotangent, which is cosine theta over sine theta. You can put this over 1 if it makes it easier to visualize. But here's what's going to happen. That sign cancels with one sign in the numerator, and this one cancels with the other sign in the numerator, and I am just left with cosine theta, and that's what I have on the other side as well. So that one's kind of simple. All right, last one. Looks like it's going to be the most involved. Let me scroll down here a little bit. So I'm going to tackle the right side here. Cosine theta is just going to stay cosine theta. Tangent theta now can become sine theta over cosine theta, and cosecant theta is 1 over sine theta. So look what happened here. Sines cancel, cosines cancel. So everything on the right side basically can be simplified to a 1. All right, so that's good to know. Now I just need to get this expression equal to 1. Well, first of all, I'm starting with cosine theta plus sine theta squared. Now, it's not the same as cosine squared plus sine squared. So what I need to do with this is I actually have to do FOIL on this. All right, so I'm going to go a little bit quickly here. I'm going to go cosine times cosine is cosine squared theta, plus sine cosine is going to be plus 2 sine theta cosine theta, and sine times sine is going to be plus sine squared theta. My denominator, I can't really simplify it all. It's going to be 1 plus 2 sine theta cosine theta. Well, now, if you remember your Pythagorean identity, I've got a sine squared here plus a cosine squared there, so I can replace those with a 1, and what that leaves me with in the numerator is 1 plus 2 sine theta cosine theta. My denominator is also 1 plus 2 sine theta cosine theta. And then obviously those cancel out and leave you with 1. We have 1 equals 1, and we are done with that identity. Okay, so that concludes the Day 6 notes. Please refer to my Schoology page and do the associate homework. And please make sure you're checking all of your answers with the homework keys. Okay, thanks guys.